So last time we looked at what an indifference curve is. Now what we want to do is put those two items together. So we want to consider what the budget constraint is and what the indifference curves are. And as we combine those two things, that allows us to now consider what that optimal combination of granola and Pop-Tarts is. So let's take a look at what happens when we combine those two pieces. So what we saw last time is that we have a budget constraint, and that budget constraint is the constraint on the Pop-Tarts and granola that we can afford. So remember, this was 10 and this was 5. And then from there, we looked at an indifference curve. And the indifference curve is all of the combinations of goods and services that give us the same level of total utility. And remember, we found that that optimal combination of Pop-Tarts and granola was 4 ounces of granola and 3 Pop-Tarts. That gave us a total utility of 770. And when we looked at that and we asked the question, how do we know that that 4 and 3 is the optimal bundle, and we said it's 770, that the easiest way to look at that is to consider the marginal utility of the dollar spent on granola and compare that to the marginal utility of the last unit of a Pop-Tart compared to its price. So we have the marginal utility of granola divided by its price, the marginal utility of Pop-Tarts divided by its price. And from there, what we saw is actually that these two things are equal. Now, if we have the optimal combination of Pop-Tarts and granola, this statement must always be true. And we actually saw that when we were looking at that. Remember, we said, oh, well, if we move away from this 4 and 3, well, what's going to happen? As we consider, say, 3 units of granola, what does that do? That allows us, on our budget constraint, to now afford 3.5 Pop-Tarts. But what we saw, because of that kind of change in granola and change in Pop-Tarts, we saw the gain here was 45, and the loss here was 60, and so the net change was minus 15. Well, what we'd see is that's actually a different indifference curve, and that's 755. Sort of for that. As we think about then, that point that's on a lower indifference curve actually makes us worse off. And we saw the same thing if we moved in the other direction, as we moved by buying more granola and fewer Pop-Tarts. That again, that marginal utility analysis allowed us to say that still makes us worse off. Well, you'll notice I drew this in a very particular way, that total utility of 770 is that point where the indifference curve is just tangent to the budget constraint. So what does that look like in a little bit cleaner scenario? Right, so remember, that's 5, that's 10, this is granola, this is Pop-Tarts, and we have that indifference curve where total utility is 770. So why is it that this point here, where these two curves are just tangent, why is it that that's the point that maximizes our utility? Well, we can see in the previous graph that this point here on the lower indifference curve, even if we look at the two combinations that are on the budget constraint, we're spending all of our money, but we're not maximizing our utility. Because there's room between those 2 points on the budget constraint, that tells us that there's some other combination that must be higher. And in fact, if we zoomed in, if we kind of looked at this piece here, but blew it up a little bit, what we'd see is that we have the part of the budget constraint and the indifference curve in this area in between those. That's where we know there's some combination of Pop-Tarts and granola that's going to actually give us a higher level of total utility. And That's what this point of tangency shows us. What we see, though, is that there's two really important concepts here. As we think about the marginal utility per dollar spent being equal, that gives us insight into something that we really want to know, the consumer's preferences, and something that we can actually observe in the world around us, prices of the goods and services. And now I want you to go back and remember, what did we say? What was this 5? How did we find that? Remember, that was what? That was the income divided by the price of a Pop-Tart. This 10, that was what? Income divided by the price of granola. And so the slope of this budget constraint is really what? It's the change in the vertical axis over the change in the horizontal axis. All it's saying is how much granola do I give up to gain how much of a Pop-Tart? And so all that is the amount of granola all over the amount of a Pop-Tart. And this gives us basically the ratio of the prices. And of course, this is downward sloping because I have to give up granola to gain Pop-Tarts. So this whole thing is negative. But what's the slope of this indifference curve? Well, remember, the indifference curve is what allows us to hold total utility constant. And so this indifference curve then is really now talking about what happens is I give up some granola and gain some Pop-Tarts. If those 2 points are what? They're not the same income, but they're the same total utility. Well, that means when I give up granola, I'm giving up utility. Well, what utility am I giving up? That's the marginal utility, right? And that's negative. And I'm what? I'm gaining the marginal utility of the extra Pop-Tarts. And so remember, a point of tangency here, that has the same slope. So the slope of this indifference curve, right, the marginal utilities, has the same value as the slope of this budget constraint. The budget constraint, that's something we observe. Utility is something that we don't observe. So now let's look at what we know and compare that to what we want to know. The nice thing is that as we look at that optimal condition, the marginal utility divided by the price of granola is equal to the marginal utility of a Pop-Tart divided by its price. And this really tells us that that last dollar spent gives us the same benefit across granola and Pop-Tarts. That must be true in the optimal. But it also allows us to take something that we observe and tells us something about what we want to know, which is the utility or preferences. So as we take this expression, we can just rearrange it a little bit. In fact, if we multiply both sides by the price of, say, Pop-Tarts and move it over here, and then use marginal utility and move it over there, what this allows us to do is, say, take the price of a Pop-Tart, multiply it by the marginal utility of granola divided by its price, and we now know that the marginal utility of this, and then again we need to multiply both sides. So now we see these things kind of cancel out, and then what we're left with is we need this marginal utility over here, so we divide both sides by that, and what we're end up with is the ratio of the prices must be equal to the ratio of the marginal utilities. And the good news is this is something that we directly observe. We can go out into the world and we can find out what is the price of a Pop-Tart, what is the price of granola. And that then gives us insight into the marginal utility that people are deriving from both Pop-Tarts and granola. And in fact, this ratio over here, this is the marginal rate of substitution. It's telling us the slope of this indifference curve and the slope of the budget constraint. Now remember, we're talking about giving up one of these and gaining the other, so both of these are negative. And it doesn't really matter which direction we're moving. So what we've seen here is that there's really two ways to consider that optimal combination of granola and Pop-Tarts. We can either look at it as we're spending each dollar and we can kind of go through that process, or instead we can look at it from an indifference curve perspective. We could say each one of those indifference curves gives us the same level of total utility. What's that highest indifference curve that we can get to, yet still be within the budget constraint? That is the indifference curve that's just tangent to that budget constraint. And that's what allows us to look at the optimal bundle. What we'll do next time is now consider what happens when there are changes. We all know prices aren't constant, and even our income isn't constant. What do we do when those pieces of information change?